Hello and welcome to this mini series using Rhino 8 and Grasshopper. In this video what we're going to have a look at is a different input for Grasshopper so that we can use curves to give the control for the structure for a barrel vault style solution. We're going to type Grasshopper and open up that window so that we can see both views at the same time on the screen. And we're going to create in Grasshopper first, we're going to create we can see the blank screen here. We're going to create a barrel vault solution that we will have done in the previous Grasshopper tutorials, but this time we're going to use a different input. We're going to use a curve input. So what we want in Rhino is some controlling curves, and I'm going to create a line, a straight line along the x-axis, and this is going to be about 20 meters long. So 20, 1, 2, 3, which is quite a long line, and then we're going to copy this, C-O-P-Y, and we're going to space that apart by about 10 meters. 10, 1, 2, 3. And there we go. So we have two lines which are parallel, and we're going to create a barrel vault style solution from this line across to this line along the length of the roof. So what we need are some inputs in Grasshopper. We can type curve, and we're looking for the black hexagonal input for a curve. We're going to Control C and Control V so we can create two curves that we're going to select from Rhino as the controlling start points. So let's select one curve, right hand click on the curve element. We can see that it's turned green. We can click on the background in Grasshopper and we can click on the item and we can see that that line is definitely green. We can right hand click on the second curve and we can choose the second curve along there. We can click on the background, we can click on the curve, and we know that those are active. So what we want to do is divide the curve into a number of points. So we divide the curve, and the default for this particular item is 10, but we're going to specify a different number of points. We'll say 15, and then we can connect the 15 slider to this particular curve. We're going to replicate this, Control C, Control V, and we're going to connect the second curve to this point. Okay, so now we've got two curves which were our initial input. We've got a division count of 15, and each of those lines is a series of points that have been subdivided along the way into the number of divisions we specified. So what we want to do is connect those together with a line. So we can double click on the background, type the word line, and we can select this line element here, and we can choose the points on this side that connect into end A, and the points on this side we can connect into end B. So we've now got a series of lines going from each of those points. We're going to find the midpoint of these lines, so we're going to put point on curve like so, and we're going to select the mid, which is 50% along the length of those lines. So we can specify a point, and we're going to move that point, so we need a move command here. We connect those points to the move, and the transition that we need to make is in the Z axis, so we can do a unit Z transition like this. And what we want to do is amplify that, so we can choose a slider, maybe select 5,000 like so, and when we connect that to the slider, we can see slider we can connect to this transition. We can select these points. We've got some start points over here, we've got some end points over here, and we've got a curve that we can fit between 3 points. Let's just reduce that down a little bit. Okay, so we can do an arc between 3 points like so. So we said we had the start points over here, that's these points, we've got the middle points here, and we've also got the end points over here. So let's connect all those through. Now we've got those arches. Just to see those a little bit clearer, we can turn off quite a lot of these items, so we can preview those off, and we can see those arches like so. Okay, so what we're also going to do is loft those curves into a surface, but what we want to do first is to make a grid. So these are curved lines at the moment, so we need to divide those into a number of points. So we can use a divide curve item again, and we can divide each of these into a number of points. Again, it defaults at 10, so we're going to specify a different number. We can Control C, Control V this slider down here, and we can connect this one, but this time we're only going to need about 5 or 6, I guess. Maybe let's go with 5 like this. We need to connect that through to this division line, and now we can see that we've got 1, 2, 3, 4, 5, 6 points in 5 divisions. 1, 2, 3, 4, 5. So that's good. Okay. And what we can do with those points is recreate those as polylines, which would then be faceted rather than curved. So this will create a series of facets. We can click on the arc, and we can see that the facets are now following the line of the arcs, but are deviating from it. So if we turn those arcs off, we can now see that the grid will be created by these polylines, and there's quite a clever little path mapper that we can use. We're going to make these the data in these items simple. I want to show you what I mean by that. At the moment, this is a branch level of information, so the first curve is in this level of the branch, and at the moment there are 3 branches. So if we simplify the configuration, we now only have 1 branch, and each curve is in its own branch. So that will make life a lot simpler when we come to plug it into this mapper. We can double click on here, and now we're going to put something in curly brackets. We've got an A, let's do a capital A in curly brackets, ordinary brackets with an X. This is the data structure. What we want to do is to remap that so that X is in the curly brackets and A is in the ordinary brackets. And then what we see is if we use a polyline, we can now create the grid members longitudinally. So we've got cross-sectional grid members, longitudinal members. We can preview all of these off, and this is now our grid. So what we have the benefit now is being able to change the number of configurations in the short direction of the grid and also the long direction of the grid. So we can choose the configuration that we require, and we can even change the height of the grid. So it could be 0, or it can go to any radius that we particularly like. So that's all well and good, and what we're going to now explore is what we do if we change some of these lines. So what I'm going to do is copy these 2 controlling lines. Let's just move them along the way a bit like this, and if we create a line here, let's say 2 meters like so, and we can copy this across to here. That's not quite there, is it? Let's move that across a bit. There we go, that's good. And we create a new line which is following this path, which is no longer parallel, but we're going to use those as our inputs for the same Grasshopper script. So we just now clear this data, and we can clear this data. We can select our first line, which is this line, and we can select our second line, which is going to be this line, and now we've got what resembles a conical barrel vault, which with a constant height all the way down. So what we're going to do is just change the height here to be a proportion of the horizontal distance between the two lines. So this line length here, we can preview that back on. This is a line, we need the length of this line. So we're going to type in length, like so, and then we're going to have a multiplication element here, and we need a factor, so we're going to have 1.00 as a slider. Let's choose something around about, say, 30%, 0.3. Okay, and we can plug this length into here, and what we can do with this output is plug it in as the amplitude for this conical grid, and we can preview off the lines. So now that we can see the height is diminishing as well as the sides, so this would be truly conical, and if we were to go to a point, that would come right the way through to a point. Okay, so this is interesting. What we can now explore is the possibility of creating some different boundary lines again. What I'm going to do this time is copy these short lines, which are actually 2 meters, and we're going to copy from here into the middle section like this. And now what we're going to do is create a boundary line which can be made up of a number of elements rather than just straight lines. So we're going to have 2 lines here like so, and we're going to join these together like this. And we can get rid of, move those across. Let's just move those down the bus along out the way over here. Get rid of those lines, and we're going to use the same configuration again, but we're changing the inputs to be these different lines. We're going to clear that value, and we're going to clear that value, and we're going to use these 2 lines here as the controlling boundary curves for the roof that we would like to create. Okay, so now this is giving us a transition from a barrel vault roof into a conical roof, and those boundary lines we can do in any manner of directions. So at an extreme we could possibly look at creating something which follows a curved line. So if we were to have maybe something that looks like this, and maybe if we were to, I don't know, maybe we could perhaps create a mirror of that curve. Type in the mirror command, and we can mirror that all the way down the bus so that it's like this. We can move those lines to the ends here. Now then, if we clear the data from the previous example, and if we reset the curves for these like so, we now get something that is a lot more shapely, just using exactly the same Grasshopper script, we've only changed the inputs and we get a completely different style of roof. Okay, so the last example that I want to show here is what we can do with the same routine, but this time we're going to create what I hope to be a dome structure. We're going to split this circle into two parts. Object to split is the circle. The splitting line, cutting object, is going to be the middle line. So now we have two lines like this. If we deselect the inputs for these and select one curve on this side and select one curve on this side, like so, we can now create a dome configuration because we have different boundary lines which are in different directions to each other. So when I click on this line and I go up to the direction of the curve, we can see it's rotating in this direction. If I select on this line, we've got go around this way. So this is the direction. If I were to change the direction of one of these curves, maybe at this point, then we would get a different style of barrel vault roof, like so. And this is quite powerful because this can give you lots of different styles of roofs within the same Rhino script, Grasshopper script, just by changing the boundary lines of how we control each of these and the direction of these boundary lines as well. So we can go from being a dome to a barrel vault style quite quickly just by changing those directions. What I'm going to do is create another final solution. If I create a dome here which will be a diameter of 20, I think, did I say 20? 1, 2, 3. Oh no, that's very small. Let's start again. We create a circle, diameter 20. Oh, that's very small. Okay, let's use these again. So if I copy each of these curves, move those down the bus. Okay, we can rejoin these into a single circle. So this is now one circle. We can divide this into 12 points. Divide. Into 12, like so. That's good. And then we create some smaller circles. Switch on the point control. What we're going to do here is create this boundary, which is even more complex, like so. And we can join these together to make one boundary line, like this. And we can mirror that to be all the way along the line here. So now what we'll do is remove those particular inputs, make sure they're cleared, and then we're going to reset one line here and reset one line here. Okay, so now we've got this odd looking barrel vault shape thing, which we can divide into a number of pieces in both directions. We can have as many configurations as you like in this direction, and we can have multiples of possibly 6 would be good. So if we went to 24, that would make sure that we get right into this point here because we've got 6 controlling elements. What we're going to do is also change the direction of this one curve so that it goes in the opposite direction. And then what we've got is what I call a jelly mold style solution. What I would like to do is to loft a surface over these arcs, and now you can see that this would be quite a nice style solution. Okay, I hope you've enjoyed this exploration of Grasshopper script for a barrel vault style roof, and we've made barrel vaults using different boundary lines and also dome configurations. Thank you for your attention. We'll see you in the next video.